Hello, Colin here. In this video, we're going to look at anonymization, pseudonymization, and de-anonymisation. Some big words there, but we'll get those explained. So the first issue we really have to deal with is why we would want anonymous or pseudonymous data. So data can provide some very valuable insights into data subjects. And that's not always a bad thing. Like, we often think about Amazon and Google and Facebook trying to find out things about us. But I mean, analysing data can be useful as well in good ways. So it can improve health outcomes, for example. It could improve education. Analysing data could improve government policy, for example. So we might want to process data about people. So what's useful is that data can often provide the insights that we're looking for without reference to any specific individuals. So if we wanted to figure out if a particular intervention helped people to quit smoking, I mean, we don't need to know if, Dan Murphy from Killorglin, quit smoking or not. We don't care about individual people. We just want to know, on average, does this thing work? Similarly, we might want to figure out, if we're working in education, does a weakness in a certain part of a course affect performance in other parts? That's a reasonable thing to want to do. And we might be able to do that without actually, keeping all of the data about everything everybody did. Similarly, we could try and figure out, does a particular government program improve jobs prospects? Maybe it does, maybe it doesn't. We can analyze the data and see if that would work. So data can provide insights without specific reference to individuals. And we can process data and analyze data without the information about the individuals and still get stuff out of it. But in order to protect the data subjects, the data might be pseudonymized or anonymized. So what's the difference between anonymous and pseudonymous? I'm always tempted to say pseudo-anonymous because it's kind of anonymous, but no, it's not a typo. So it's clear that data collected on individuals can be processed to extract some insights out of that, and we can preserve privacy then by removing any identifying information from the data set. So here, imagine I'm a lecturer and I have information about students' names, IDs, the marks they got on a particular question and their final marks. If I wanted to analyse that data in the broad sense to get insights into what was working and what wasn't working, I can do that without the information identifying the particular students. So I can remove the identifying information entirely. So anonymous data sets have the personal identifiers removed. So I would remove the names. And in this case, I would also remove the ID numbers. So this is entirely anonymous data now. So it can still tell me, what the average mark was for each question. It can tell me what the average mark was for the class. It can even give me the insights I'm looking for into things like, does performance in question 1 affect question 5? I can either answer questions like, has the mark for question 1 on average improved over the years? So anonymous data can still be very useful. Now, it's limited though, and that's part of the problem. Suppose I wanted to know what was the average overall mark for the year for a particular student. Well, all I have here is anonymous data about the students that were in my class. If I wanted to combine that with information about students who took with the same students that took a different module, I wouldn't be able to connect the dots there. Similarly, if I wanted to know, does performance in this module affect performance in subsequent modules, I couldn't do that because there's no way to connect this data set to the other data set. So because the sets can't be compared, it can be more restrictive and less useful. So this is where pseudonymous data comes in. So pseudonymous data sets then have the personal identifiers separated from the data, but not destroyed, not completely gone. So here I can store the information with the student ID number, which doesn't identify the student in the data set as such. But if I need to, I can go back to the ID numbers and map them to the names. So if it comes to it, if there's some reason why a student needs to be identified, that can be done. And in the meantime, the identifying information can be kept secure. So if the table here on the right was released, and became public, in order to get any information about individual students, a person would have to have the mapping of student ID numbers to names. Now, in reality, when we use pseudonymous data, we wouldn't use something as mappable and as easily usable as the student ID number. We would probably generate random identifiers based on the identifying information. We might even use a hash function to do that. We could even possibly, depending on how you wanted to do it. But so you can get the idea here that if you don't have the mapping of student ID numbers to names, it's reasonably safe. But using ID numbers in anonymous data, of course, wouldn't be the way to go. So the value of this then is that if I want to see how a student did, well, no, not a student, if I want to see how students did across other modules and the relationship between the modules, and if doing well in one module has an impact on another module, I can use the ID numbers to map the data I have on the students in my module to results the student might have had in other modules. And so the common key in the tables then allows the data to be mined and to be analysed for those insights without ever identifying the student as such. And that's important. So we still don't know the names of the students, but we can connect this data to other data. So you could imagine a scenario where you would use maybe a person's ID number or, in Ireland, a PPS number. Now, in Ireland, PPS numbers cannot be used as identifiers in this way. It's absolutely verboten. But you could see how if you had people's PPS numbers, you could connect up tables and connect up things and figure out, does giving someone this extra welfare entitlement reduce the incidence of smoking or make it worse, for example. You could connect up all this data and figure out things without necessarily being able to identify the individuals. So the privacy would be preserved while the data could at the same time be extracted. Now, the big question then, though, is how anonymous is anonymous data? And this is a very big problem and a very big question that needs answering. So suppose we have information here about individuals, and we have their dates of birth, sex, height, weight, postcode, and we have the prescriptions for their eyes, for example. And let's say we had other information about them, whether they're smokers, non-smokers, whatever. But let's just look at this here now. So privacy can be preserved by removing some identifying information from the data set. So let's say we wanted to analyze this data for outcomes that applied on average, for example. So if we wanted to see if there is a correlation between a person's good or bad eyesight and their weight, for example. Well, we might decide, look, we're going to release this information out into the world. We're going to give it to our best statisticians, and they're going to come up with some fabulous insights for us that can make all of our lives better. And sure, it'll be grand because we're taking away the names. Now, Yeah, but I mean, we can see some problems here already with this. So you have to make sure that the data itself isn't capable of identifying people in some way, even though the identifiers have been removed. There may be something in there. So the postcode here is a big issue now. So in some countries, for example, the postcode is shared by many people. So it's very common in data sets from the US where you would have the zip code, and this is the area code where someone is from. In the UK, we also have the postcode, it's called, and this is quite a big tranche of, space that many people share. But in Ireland, it turns out the postcode identifies an individual single home. So with a person's postcode, you can tell exactly where they live. And so if we look here at P31, D521, there may only be one person at all living there. There may only be one male living there. And there's certainly probably, well, not certainly, but it's very likely there's only one male living at that address with that date of birth, for example, unless there's identical twins living there or something. But you can see how releasing anonymous data that has the postcode preserved in Ireland would be a catastrophe. So we could do something like only keep as much of the postcode as is useful. So if we were to keep the most significant digits of the postcode, we could see if there was a correlation between, your eyesight and where you lived. Maybe people who live in Dublin have really good eyesight compared to people who live in Cork. Who knows? But you could extract that information perfectly fine using just the first 3 digits of the postcode, and you don't need the whole postcode at all. So in a scenario like this, for example, this would be data minimization, where we're storing only as much data as we need in order to achieve the objective. We could even, rather than using postcodes, which could be quite specific, I mean, you could imagine that a tract of land in Dublin city centre that has a particular postcode could have many, many people in it. But if you were to take a sparsely populated, part of the mountainous part of Ireland, up Ballochasheen or something, you might find that in a particular postcode there's actually very few homes. So you might decide what you want to do is just store the actual townland or something. So here now we could say there's a male, 176 centimetres tall, weighs 110 kilos, and he's from Ballincollig, Cork. There now, forgive the typo, we know Ballincollig isn't in Kerry, Ballincollig is in Cork. Okay, so you could see how this could be an improvement. But of course there's a big problem here still with the date of birth, isn't there? That's perhaps just too much information. Like if we take, say, a place like Ballincollig, which is quite populous, I mean, the number of people that would share a specific date of birth could still be, reasonably small. I mean, you could work out the stats but I mean, the possibility of the birth date being unique, for example, is certainly on the horizon. So that kind of information could possibly identify someone. And the thing is that the actual full date of birth is way more information than we need. So if we're trying to analyze this data in order to figure out, some sort of correlation between whatever and whatever and whatever, maybe we don't need the actual date of birth. If all we need is the person's age, well, then maybe the year of birth is perfectly fine. So now we've reduced the location down to, a general town, and we've reduced the date of birth to just a year of birth. And the chances of someone being born on the 1st of May and the difference between being born on the 1st of May and the 2nd of May isn't going to make any difference to our analysis. So that's something that we could do. That's data minimization, where you store as little information as possible and only store the information that you need. But then even when the data has been, reduced as much as possible, where there are lots of individuals that share the same attributes, even when there are lots of them. Like the combination could be quite specific. So, I don't know much about Killorglin, but I'd say I think it has about 2,000 people living there, I'd say. You'd wonder how many tall, skinny men with glasses born in Killorglin are there? Born in 2000 are there living in Killorglin now? And there might not be that many. So if you had some very sensitive information about this individual here, you might say, well, it's impossible to identify people from the date of birth. From the year of birth. There are sure hundreds of people born in that year. Half of the whole population is male. The height is in a very common range. The weight is in a very common range. But combining the pieces of information, the intersection of those could actually identify an individual. So where the population might be small, that might be enough. Someone looking at that could, that's probably Tom Murphy, your man. Someone might actually be able to identify the people based on the information. I think if you're a computer scientist from a large city like Paris or London, this possibility seems quite remote. But when you're living in Ireland, we know, do you know what I mean? You could probably tell in a lot of places who's who just from looking at the data. And so there have been two very well documented de-anonymisation disasters. So both of these were actually large data sets released to the public in the interests of computer science, I suppose, for want of a better description. And so one was AOL and the other was Netflix. So in 2006, AOL released large amounts of anonymized user search data. So all the user identifiers were removed. So the information that would identify the individuals was completely removed, but the information itself was able to reveal who the person was. So sometimes, people search for themselves or they search for their relatives. They might search up their things in their locality. And what researchers were able to do was, looking at the data, they were able to actually identify some people. And some journalists then even phoned them up and explained to them what had happened. And of course, they were horrified, and rightly so. But these were very graphic horror stories then of what can happen and how data, can it really be de-anonymized satisfactorily? Some researchers did a very, very interesting analysis that makes it easy to understand, I think, the way this problem works. And like small, insignificant pieces of data can add up in aggregate to something very big. So if you consider, for example, two people, Victoria and Albert, okay? So let's imagine that Victoria posted some pictures of her in Amsterdam on February the 14th. And let's say that Albert was also in Amsterdam on February 14th, and he also posted some pictures on Instagram. Well, what can we say about Victoria and Albert in this situation? Nothing. We can say absolutely nothing about their relationship. There were millions of other people in Amsterdam that day. The fact that two people were in Amsterdam on the same day is not something from which we can draw any conclusions whatsoever. Let's suppose then that Victoria was in Geneva on the 20th of February and posted to Instagram on that day, and Albert was in Geneva on the 20th of February and he posted to Instagram that day. What can we say about that? Well, nothing. There were thousands of people in Geneva that day. Geneva's a very busy spot, people coming and going a lot. We can infer nothing from that tiny nugget of information. Suppose then Victoria was in Paris on the 4th of March and Albert was in Paris on the 4th of March. Again, millions of people in Paris. Nothing can be drawn from the fact that two people were in Paris on the same day. Suppose Victoria was in Gdansk on the 12th of May and Albert was in Gdansk on the 12th of May. Thousands of other people in Gdansk that day. Again, on its own, that means nothing. Suppose Victoria was in Vienna on the 24th of May and Albert was there on the same day. Vienna is a very popular spot. What can we say about that? On its own, nothing. Suppose they were both in Granada on the 4th of June. Suppose they were both in Malaga on the 6th of June. Suppose they were both in Malta on the 1st of July. Suppose they were both in London on the 4th of July. And suppose Victoria posted to Instagram that she was in Cork on the 7th of July and Albert was in Cork on the 7th of July as well. So what? Lots of people were in Cork that day. But here's the thing. So the fact that Victoria and Albert were both in London on the same day means nothing by itself. Millions of people were in London that day. But the number of people who were in Amsterdam on the 14th of February and in Geneva on the 28th of February and in Paris on the 4th of March and in Gdansk on the 12th of May and in Vienna on the 24th of May and in Granada on the 4th of June and in Malaga on the 6th of June and in Malta on the 7th of July and in London on the 4th of July and in Cork on the 7th of July, well, that's actually quite small. It's a very small set of people. So if you had the capacity to analyse all of that information, you could probably conclude that Victoria and Albert are actually known to each other. And so you could infer a relationship between those two people, even though individually those data points mean nothing on their own. And each new data point, like new point, narrows the probability of a coincidence. So this then is pretty much what happened with the Netflix de-anonymisation disaster. So Netflix was renowned for the quality of its movie recommendation system. So when you watched a movie on Netflix, you would rate it and say, I liked that, I didn't like that. And based on what you liked, Netflix would say, oh, you might like this. So Amazon kind of does a pretty good job of this too. But Netflix was actually quite renowned and very proud of its algorithm. It often was quoted as saying, that was one of its most important assets. It was this algorithm it had and the data it had that it could use to recommend movies. Because, if somebody likes a movie and then they also like this other movie, well, then another person who likes the first movie might like the second movie, But Netflix wanted to improve the quality of its recommendation system even further. And so what it did was it released the data set, a large data set of customer movie ratings. And it completely stripped out entirely any identifying information. So it was just, random user 72 liked this, and this. And random user 79 liked this, and this, but didn't like this, and this, and this. And so what it was able to do then was it was able to keep a separate. What you do in AI is you can test the quality of your algorithm then by testing it on a piece of data which it wasn't trained. So Netflix then was able to, if someone came up with a new algorithm, was able to assess how good it was, right? But there was a big problem because although there was no identifying information, some customers were actually identified. And the reason was because there was another website where people rated movies. This was called the Internet Movie Database, IMDb. And on IMDb, people were identified. So you could go on to IMDb and say, I liked this movie, I hated this movie, I loved this movie, I hated this movie. And that was fine. People were identifying themselves on that website, saying I liked such and such. And that was their choice. But researchers were able to compare the movies that people liked and disliked on IMDb with movies people liked and disliked on Netflix. This now occurred where someone was both a subscriber to Netflix and a subscriber to IMDb. So in this scenario, it was possible to compare the likes and dislikes on one with the likes and dislikes of the other, and then say, haha, okay, so this particular anonymized customer on Netflix is actually this person here on IMDb. And that's not such a big deal were it not for the fact, of course, that some people were watching things on Netflix that they perhaps were not rating on IMDb. People assumed that what they were watching on Netflix was private information. But of course, if you could connect the anonymous user to the IMDb identifier, then you could say, this person watched these movies. And this actually resulted in some gay customers being outed as gay. And obviously that was a big problem. So even totally anonymous data can potentially be de-anonymized. And that's something that has to be considered. So in summary then, we have minimization, which is storing as little as information as possible. So you have a task that you want to complete. That's fair enough. That's a legitimate and reasonable thing to want to do. But you should only use as little data as you can make do with. Psudonymization is separating out the actual identity of the data subject from the data set, storing the identifying information, the mapping between the identifier and the identified separately from the data set. So if you ever have to go back to identify, you can, but also it allows for processing that can use the the pseudonymous identifier to connect to other data sets that use the same pseudonymous identifier. Anonymization then is removing the identifying information entirely. And this, of course, can be more secure, but it does also result in less useful data. And then the final thing we need to consider is that even when data is completely anonymized, it may actually be possible to de-anonymize that data.